So now we continue with our exercise of indices, that is exercise number 7 of standard 9th ML Agarwal. Okay, we had completed till sum number 20 in the last video, so we start with sum number 21, that is exercise 7, sum number 21. We are doing the alternate sums, so we are doing the first one of sum number 21. It is given as a plus b the raised to minus 1 and a raised to minus 1 plus b raised to minus 1 is equals to 1 upon ab. This is show that, okay, this is prove that. So we have to prove that the LHS equals to RHS. This is what you need to do in this case. So we have over here the first one is LHS. Now whenever you have got any proof that sums, remember, whenever you have got any proof that sums, you cannot write this thing completely from the start because you have to prove this thing. So here we'll take the left hand side separately, solve it, right hand side separately, solve it, and then say LHS equal to RHS, hence proved. Okay, so remember this thing, whenever any sum is written as prove that or show that, you have to use LHS and RHS method. So you have to have separate calculations for the left hand side, separate calculation from the right hand side, and then you have to prove that left hand side equal to right hand side, hence proved. Okay, so over here left hand side is RHS is 1, so a plus b raised to minus 1 and a raised to minus b plus b raised to minus 1. Okay, so here it is 1 upon a plus b into 1 upon a plus 1 upon b. So this gives me 1 upon a plus b. The LCM over here is ab, so into b plus a upon ab. So this b plus a and a plus b gets cancelled. Hence it is 1 upon ab, which is nothing but the RHS. Therefore LHS is equals to RHS. We say hence proved. Got it? This is how we are going to show this particular kind of sums. We now move on to sum number 22. Sum number 22 is over here. Now we can see that in sum from 22 onwards, they have given you only one single sums. So we will start with this way, that we are going to do the 20 instead of okay, we'll do 22, 24, 26, 28, 30, 32, 34 में फिर options है, 35 में options है, and 36, 38 and 40 में options है. We'll do that way. Okay, so let's start with sum number 22. We got that if a is equals to c raised to z, b is equals to a raised to x, and c is raised to b raised to y, prove that x, y, z is equals to 1. Okay, we have got over here a is equals to c raised to z, b is equal to a raised to x, c is equals to b raised to y. So you just take over your first case at a. So a is equals to c raised to z. Now if you take the value of c over here, what is c over here? This is nothing but c is nothing but b raised to y. So it is b raised to y the whole raised to z. Right? Because since c is equals to b raised to y. Now we know that, so it will be b raised to yz. So a raised to 1. Okay, this is 1. So a raised to 1 is equals to b raised to yz. Now what is b? B is given as a raised to x. So a raised to 1 is equals to a raised to x into b yz, sorry, into yz. This is because since b is equals to a raised to x, accordingly what happens is a raised to 1 is equals to a raised to x, y, z. Since the bases are same, so the indices also be same. Therefore x, y, z is equals to 1. Hence proved. Understood? So slightly tricky one, but easy. If you understand it properly, it is easy because you can see that you are just substituting the values in each case. You are just substituting the values. There's nothing else we are doing extra over here. पहले C का value डाला, फिर B का value डाला. That's it, and you got the answer. Okay, so this was sum number 22. We come to sum number 24 now. Sum number 24, we have got 2 raised to x is equals to 3 raised to y is equals to 6 raised to minus z. We have to prove that 1 upon x plus 1 upon y plus 1 upon z is equals to 0. Okay. So, in this case, we can see over here that all these numbers are different. So we can take this as 2 raised to x is equals to 3 raised to y is equals to 6 raised to minus z is equals to a letter k, which is a constant because everything is equal. So I can just take it as a value k. I took it as k because x, y, z everything is already used. So I think better will be k, which is constant. So k. So accordingly you get that 2 raised to x is equals to k. 3 raised to y is equals to k and 6 raised to minus z is equals to k. Right. So now if you see this, you get over here that 2 is equals to k raised to 1 upon x. 3 is equals to k raised to 1 upon y. And 6 is equals to k raised to 1 upon minus 1 upon z. Okay. So this is what you are getting over here. Now, we know that 6 is nothing but 2 into 3. So, we have over here that 6 raised is equals to, we can write 6 is equals to 2 into 3. So, k raised to minus 1 upon z is equals to k raised to 1 upon x into k raised to 1 upon y. Are we clear with this? So we can say if I take this on the other side, it will be 1, right? It will be 1. So it will be 1 is equals to k raised to 1 upon x. Now this is nothing but a raised to m into a raised to n is a raised to n plus n. So it is 1 plus n upon k raised to minus 1 upon z. Now what is 1? K raised to 0. So we have k raised to 0 is equals to k raised to 1 upon x plus 1 upon y minus of minus 1 upon z. So we have k raised to 0 is equals to k raised to 1 upon x plus 1 upon y plus 1 upon z. Bases are same, therefore exponents will also be same. Therefore 1 upon x plus 1 upon y plus 1 upon z is equals to 0. Hence proved. Got it? Understood this one? Very important question. This was given to you. So you took this as a common value k. Once you have the common value k, you know that this is 2 raised to x is equal to k. Then what will be k? K will be 2 raised to x will be k raised to 1 upon x. So basically what you are trying to do over here is multiplying both the numbers by raised to 1 upon x. So this 1 upon x में x cancel हुआ और यहाँ पे 1 upon x आ गया. इसे इधर भी y इधर जाएगा तो 1 upon y. This will be minus 1 upon z. Okay, this is how we are taking the value of 2, 3 and 6 separately over here. Once you get the values of this thing, then you are just finding out the thing by 6 is equal to 2 into 3. Got it? So this gives you the thing as 1 is equal to this much, and hence you k raised to 0 is k raised to 1 upon x plus 1 upon y plus 1 upon z. So k 1 upon x plus 1 upon y plus 1 upon z is equal to 0. Okay, so that was the question number 24. We move on to question number 26. Question number 26. We have simplify and express with positive exponents. That is the first one, 3x square raised to 0. A simple thing, you just have to convert it into a simplify it and convert it into a positive thing. So this is anything raised to 0 is 1, so it is just 1. Okay. The next one is xy raised to minus 2. So this we know it is nothing but 1 upon x square y square. If you want to make it in a more detailed manner, that will be 1 upon x minus the whole square, so it will be x square y square. Okay. And the last one is minus 27 a raised to 9 into 2 upon 3. So that is nothing but minus 3 the whole cube into a raised to 9 into 2 upon 3. That is equals to minus 3 raised to 3 into 2 upon 3 into a into 9 into 2 upon 3. So this gets cancelled to 3, this gets cancelled. So it is minus 3 the whole square into a the whole 6. So equals to minus 3 into minus 3 is 9. So it will be 9a raised to 6. That's the answer. So this was question number 26 of exercise 7. You can just check up the answers also. So question number 26 is 1 upon x square y square and 9a raised to 6. Okay, that was question number 26. We move on further to question number 28. Okay, question number 28. We have over here as if x is equals to 10 raised to 3 into 0.0099, y is equals to 10 raised to minus 2 into 110, find square root of x, y. Okay. So first of all, let's see over here that x upon y will be equal to 10 raised to 3 into 0.0099 upon 10 raised to minus 2 into 110. That is nothing but 10 raised to 3 minus of minus 2 into 0.0099 upon 110. I'll keep it as it is. So this is 10 raised to 5 into 0.0099 upon 110. So now you can see that when I multiply by, there will be multiplied by 5 zeros. So it will be 990 upon 110. Okay, this is nothing but, so that is 5 zeros. So automatically when I multiply this thing, so 1 0 gone, 2 0 gone, 3 0 gone, 4 0 gone, 5th 0 will be out over here. So it will be 990 upon this. That gives me 9. So x upon y is equals to 9. Therefore square root of x upon y is square root of 9 is equals to plus or minus 3. So you need to know that this will be plus or minus 3, because plus 3 also gives you 9, minus 3 square also gives you 9. So that's why the value of square root of x upon y will be plus or minus 3. That's the answer for question number 28. Now we move on to sum number 30. Sum number 30. If it's given that x raised to 4, y raised to 2, z raised to 3 is equals to 4, 9, 3, 9, 2. Find the value of x, y and z, where x, y and z are different positive primes. This looks very difficult, kya hai? But actually it's very easy. You know what is to be done? Prime factorization. You are just going to do this way, that you are going to take this as 4, 9, 3, 9, 2 to divide. So it will be 2, 4, 6, 9, 6. Again 2, 1, 2, 3, 4, 8. Again 2, 6, 1, 7, 4. Again 2, 3, 0, 16. So 8 and 4, 7. Now we'll try with 3 now. So 3, 1, 0, 2, 9, 3, 3, 4, 3. Then it will be not 3 anymore. So it will be 7, 7, 7 fours and then 9s. So it will be 7, 7, 7, 1. So now what has happened? This is nothing but 49392 is equals to 2 raised to 1, 2, 3, 4 into 3 raised to 2 into 7 raised to 3, which is also equal to x raised to 4 into y raised to 2 and z raised to 3. Therefore, x is equal to 2, y is equal to 3 and z is equal to 7. Did you understand this? You can see x raised to 4, 2 raised to 4. So x is equal to 2. Y raised to 2, 3 raised to 2. So y is equal to 3. Z is equal to 3, 7 raised to 3. So z is equal to 7. Understood? This is the sum. Very, very easy. We move on to sum number 32. Sum number 32 is if p plus q raised to minus 1 and this is equal to 5 proof. Okay, so we write over here that p plus q whole raised to minus 1, p raised to minus 1 plus q raised to minus 1 is equal to p raised to a and q raised to b. You have to prove that a plus b plus 2 is equal to 0. Got it? So let's see. First of all, because this is given to us, you don't need to prove this thing. So I need not take LHS RHS. It is already there in this form. So we have over here that first thing is 1 upon p plus q into 1 upon p plus 1 upon q is equals to p raised to a, q raised to a, q raised to b. This is 1 upon p plus q into q plus p upon pq is equals to p raised to a, q raised to b. P plus q, p, q plus p, one thing, so cancels. So 1 upon pq is equals to p raised to a, q raised to b. Accordingly, we say p raised to minus 1, q raised to minus 1 is equals to p raised to a, q raised to b. Therefore, a is equals to minus 1 and b is equals to minus 1. Let's put that in value over here. So a plus b plus 2 is equals to minus 1 plus minus 1 plus 2 is equals to minus 2 plus 2 is equals to 0. Therefore, LHS, so in this case, yeah, so this is LHS is equals to RHS, hence proved. Got it? So this is the sum number 32. Okay, now read the next part.